Welcome back, year 10. Let's take a look at simultaneous equations again. This time we're going to look at the process of substitution and when it's best to be applied. What I mean by that is, take a look at this first example. So you're noticing that usually, right, the x's line up with the y terms with the constant, and usually it's set up where it looks something like this, 2x plus 3y equals 5, for example. So usually it's the constant term that's set equal to some combination of the x and the y term. In this case, if you'll notice that the y's are actually been isolated to one side of the equation here, and then you have the x term and the constant term on the other side. This is a great way, or a great example, where you can use substitution to help essentially make your life a little bit easier when you try and solve this. What I mean by that is, if you're noticing, y is equivalent to this expression here, which means wherever I see y, I can actually substitute this expression in to represent y, since they are equivalent. So what we do is, you take a look, y is isolated, so I'm going to use this expression, and I'm going to substitute in for this y here. I'm going to replace it. So 2 times, instead of y, I'm going to replace it or substitute it with this expression, 4x minus 3. The brackets are key here because you'll notice the entire quantity has to be multiplied by 2. So putting those brackets helps to remind you that you need to multiply every term by 2. Set that equal to the 3x plus 4, that hasn't changed. And now we can just solve for x. Notice that the y's are no longer there, it's just x. So we can solve this just like any old equation. Expand the bracket out, so now we should have 8x minus 6. And let's go ahead and solve for x. So we end up getting x equaling 2. Now, because y is isolated here, this actually works really nicely. Let's take that same second equation and replace x with 2 to solve for y. So y is going to equal 4 times 2 minus 3. Whoops, sorry. So let's do 8 minus 3. So y equals 5. So there you have it. There's your solution. X equals 2 and y equals 5. So can you please try using substitution to work with these two equations here and solve for x and y? Okay, let's find out. So hopefully you said, right, well, I'm going to substitute this expression in for this y. Let's see if this is what you did. So you did this, hopefully. You then expanded the bracket out and got this. Okay, then hopefully you started eliminating your x's. And then maybe you did this to get this. Okay, and then let's bring this back. So y equals now negative 8, take away 2, to get y equals negative 10. So I'm hopeful that you got x equals negative 8 and y equals negative 10. That is your solution. Okay, let's try one more. So again, look, super easy to substitute this in for that. So let me do it. And then expand out. And now let's go ahead and combine our x terms. Not a pretty one, but x equals 10 over 3. All right, let's just double check and make sure. So x minus 3, substitute in, we get 2x, we get 6. Yeah, cool. We add to get 10, we add to get 3. Yeah, it's just not a nice number. Okay. All right, let's come here. So y equals, now we have 10 over 3, take away 3. Don't forget, whenever you're taking away with fractions, you need a common denominator. So in this case, let's keep this 10 over 3, but we're actually going to be taking away, with a 3, it'd be equivalent to 9 over 3, because 9 divided by 3 is 3, which gets us a y value of 1/3. Not pretty, but the solution would be x equals 10/3 and y equals 1/3. Okay, here's your final question for today. Can you please attempt To use substitution to solve for this pair of simultaneous equations, and then go to Firefly to select your answer choice. Good luck!